So today we will start first. We will see what is the force experience or force acting between the two plates. What will be the work done, and then series and parallel combination of capacity. So force between two plates of capacitor. So in case of capacitor, what is happening? So one plate is supposed positively charged. That is the, we call it charging plate or charge plate. And the other one, we are assuming equivalent opposite charge is induced. And this is connected to earth. So this is suppose plus Q charge. This is having minus Q charge. So as they are having opposite charge, so naturally there will be force of attraction between these two plates. This will experience a force in this direction. Suppose this first plate we are saying, this is second plate. So this is F12. That is force experienced by first plate due to second plate. Whereas this one will be, this is the F21. So this will experience force this side towards positive plate. Positive plate will experience force towards negative plate. Is it clear? This one? Board is clear?
Yes, sir.
Yes, sir.
Yes. So how will you find this force? When we place any charged particle or charged object in electric field, the force is
QE.
QE. So what will be this F12 will be the charge Q1, which is equal to Q only. So this Q1 and Q2 magnitude is same, Q. Only sign is opposite. And this E1 and E2, that is also same. Suppose it is E0. Electric field due to this will be in this direction, and due to this also will be the same direction. So this is suppose E1 and this is E2. The magnitude is same. And what is the magnitude we are knowing? So this E0, E1 which is equal to E2 which is equal to E0 we are writing. That will be how much? Sigma over 2 epsilon naught or Q over 2A epsilon naught. That is the electric field. So force experienced by first plate due to second plate will be charge of the first plate and electric field produced due to second one. As Q1 is positive, so force will be in the direction of E2. So this F12 will be plus Q into how much? Q over 2A epsilon naught. And the direction is what? Okay. So this one, so it is q square over twice a epsilon naught. This is the force experienced by this plate. Now, similarly, if you find this one, what will be F21? This is charge Q2 into electric field due to E1. Now, for this charge, this will be the source which is producing electric field. So, how much electric field is produced by this plate? And due to that, how much force is experienced? So, this Q2 means minus Q, and this E1 is Q over 2 epsilon naught. As minus sign is coming, so opposite to E1 it will come. So opposite to E1 means towards negative plate, sorry, towards positive plate. Got? In confusion? Yes?
No, sir.
No, sir.
No, sir.
So what is happening here? The magnitude of this force will be same. Whatever force is experienced by this plate, same force will be experienced by this plate. Magnitude is same, only direction is opposite. This one will experience force towards negative plate. This one will experience force towards positive plate. So magnitude of the force is same. So this F21 or F12, suppose it is F, and how much it will be coming? Q square over twice A epsilon naught. So this is the force experienced. So this force does not depend on the distance d. That means whether the plates are separated or kept at 1 millimeter or 2 millimeter, the force will be same. It does not depend on d. So F is constant. So this F does not depend on plate separation. So distance between the two plates, it does not depend on that. So force is constant. Now suppose we want to increase the separation. We want to increase it. So we will have to do some work. Because earlier plate was very close. Now it is moved from here to here, distance apart. So work will be done by external agent or electric field.
External agent, sir.
External agent. Due to electric field, it has a tendency to come closer. Whereas if we apply the force in opposite direction, then only it will move. So if we want to find what is the work done by external agent. So work done by external agent in separating the plate. From 0 to distance d. Suppose now it is at distance d. Earlier this was very close. Now we have increased up to, kept up to this. So what will be? The displacement is d only. Suppose this plate is fixed. This one we have moved from here to here. So force experienced by this one is this much. In this direction, external agent will have to apply force in opposite direction. Distance from here to here it has gone. So this work done will become F into D cos 0. But external agent will have to apply force in opposite direction. And the force is constant, so we can apply easily this formula. No need to do the integration or no need to plot the graph. So it is constant force. So simply what will become? So this work done will be how much? Q square D over twice a epsilon naught. Now, this electric field is conservative. The electrostatic force is conservative force.
Yes, sir.
Yes,
So
sir.
whatever work is done by the external agent, what will happen?
Stored as potential energy.
Yes, it will be stored in the form of
Electric
electrostatic potential energy. So this work done by external agent is stored in the form of electrostatic potential energy. So indirectly, this potential energy stored will be how much? Q square D over twice a epsilon naught. As we know, epsilon naught A over D is what? C, capacity. So it can be Q square over 2C also. It can be expressed in other form also. As we know, Q is C into V, so it can be changed into that form also. It can be equal to half CV squared. It can be half QV. Because this Q is how much? C into V. C is Q by V. So this is electrostatic energy stored in the capacitor. This expression we will derive some other way also. This is one of the way of by which we can derive. Some other way also we have to know. Now energy density. That is energy stored per
Per
unit
unit volume.
Energy stored per unit volume. So it is U over what will be the volume of this capacitor? Yes.
Area into D, sir.
So area into D, because these two parallel plates are there. So if we find the volume of that space enclosed by these two plates, that will become A into D. So it can be Q square D twice A epsilon naught. A into D. D will be cancelled. So Q square but twice A square epsilon naught. Q square by A square, that is sigma. Or in terms of electric field intensity, we can find what will be the electric field intensity between these two plates. Sigma over epsilon. Sigma over 2 epsilon naught plus sigma over 2 epsilon naught. So sigma over epsilon will be the electric field. So it can be half sigma and electric field also. So this E is how much? E1 plus E2, that is net field, which is sigma over sigma over epsilon naught. So magnitude only you are interested. So this way we can find energy density. So energy density will depend on charge density as well as electric field intensity, or mainly it will depend on charge density sigma square, and this is the medium, the electric constant of the medium. In place of air, if other medium is there, then epsilon naught, epsilon r will also come. So this is force between two parallel plate capacitor, work done, and energy density. That is, when the capacitor is charged, it stores some energy. Now, another thing you have to do is maximum charge that can be given to a conductor. If we are considering a sphere, suppose we start giving charge. So when we give charge Q, electric field intensity will be developed. So this electric field intensity on the surface will become one by 4 pi epsilon naught Q over R square. So this Q is 4 pi epsilon naught R square E. Okay. So this much charge we can give. That means this will depend on the electric field intensity, how much you can do, how much you can give. Now there is a maximum value that we call breakdown electric field. Maximum electric field that can be given to any object in a particular medium. So for air, maximum electric field or breakdown electric field we can say, if medium is air we can say, if medium is air, maximum electric field of any conductor is 3 into 10 to the power 6 volt per meter approximately. If any other medium is there, just you keep on multiplying. For dielectric constant K, suppose 50, then 50 times more than this. Any medium is K, then breakdown field will be this K times this value, 3 into 10 power 6. So if maximum electric field is this much, so what will be the maximum charge? For that we will substitute this value, whatever the radius of that surface may be. Naturally, if the radius of the surface is large, we can give large amount of charge. Are you getting?
Yes, sir. But I think
Yes.
so here A by Q by A square will be there. Radius is A here. 1 by 4 pi epsilon naught Q by A.
Radius is A. Okay. So radius is A. So 4 pi epsilon naught A square E. Okay. So it will depend mainly on the radius of the sphere, because this maximum intensity will depend on the medium. If air is there, we give this much. If any other material is there, then K times that much. So for example, mica is there, maybe 50 times more we can give. So this maximum value of electric field intensity is fixed. So we can find what will be the charge. Now what will happen if you give charge more than this particular value? Naturally, intensity will increase beyond this one. So it will start leaking the charge in the air. If your medium is air, then if intensity increases beyond this one, it will start leaking the charge. That is, the air will behave as a conductor. So insulating capacity of air is up to this much. If the field is this much, air is insulator. If field is beyond this, air will become conductor. So this will start conducting the charge, that is, charge will start leaking. And that is the basic principle of lightning conductor. When the surface is pointed, suppose here it is Q is this much, when you are giving the same charge, suppose the shape of the object is like this, what will happen? Here radius of curvature is very small. So by giving same amount of charge here, electric field intensity will increase. So when we give the charge, though the charge is uniformly distributed, but here intensity will be very high, and this charge will start leaking. It will keep on going in air. So another cloud will be formed here, and when charge cloud comes in contact or very close to this goes to the cloud and it discharges. This type of discharge we call corona discharge. So mainly we have to know, sometimes it is asked, can we give 1 coulomb charge to 1 centimeter sphere of 1 centimeter? So in that case, we will have to find what is the electric field intensity. If electric field intensity is beyond this, we can't give. If electric field intensity is less than this, we can give that charge. So sometimes question is like this. Or why we can't give 1 coulomb charge to a sphere of 1 centimeter? Naturally, we will find the electric intensity. So suppose here, suppose this A is 1 meter, how much charge we can give? Maximum charge will be 3 into 10 to the power 6 over 9 into 10 to the power 9. In air, if it is air, then this is the situation. If the electric constant is 3, then here also 9, here also 9. So what will be? 10 to the power minus 3. So 1 millicoulomb. So we can't give a charge of 1 coulomb to a sphere of radius 1 meter. Then what will happen? It will start leaking the charge. It cannot keep that much charge. So how much charge it can keep? This much. That is the maximum of the order of millicoulomb only. So it is 0.33 millicoulomb. That much charge. A sphere of radius 1 meter. See how big sphere is there. It can have a charge maximum up to 0.33 millicoulomb, not more than this. Okay, so this is maximum charge that can be given, and why? So in some cases, what will happen? The discharge will start from this pointed path, not from this one. Well, when the charge is uniformly distributed, here electric field intensity will be more, always. Where radius is less. Electric field intensity Q over A square. So A is less means E is more. So from the pointed part only, the leaking will start first. That's why in case of lightning conductor, the rod's tip is pointed, so that the corona discharge may start from that point only. Okay, now we shall do series and parallel combination of capacitor. Okay. So now we shall start this one. Series and parallel grouping of capacitor. This derivation is frequently asked. So first we'll see series grouping. So there are, in class 10 we have done, there are three type of grouping. In case of resistance also, series grouping, parallel grouping, and the third one is mixed grouping, when series and parallel both are present. So that is mixed grouping, and mainly equivalent is asked based on mixed grouping only. But formula we have to derive for series and parallel. So series grouping of capacitors. So in series grouping, what will be? So same as in resistance, what we have done. So this one. So one end of this was this is first end, suppose this is second end, this is first one, this is second one. So first one of one end of this one, second resistance will be connected to second end of the first one. So same way here also we will connect. So suppose this is the charging plate, this is earth plate. Now second one's charging plate will be connected to the earth plate. So this may be so this is connected to the source, okay, which is giving the charge, and this is connected to the earth. Maybe suppose one battery we are considering. We can consider a cell only, no problem. So it is connected like this. This is positive, this is negative. What will happen? From this, with positive charge will start, or from this side we can say the electrons will come from here. So first electron will come here. Maybe some negative charge has come this place. Equal amount of positive charge will be induced here. In the inner one. Now outer one, which is negative charge, as it is free charge, so it will move to this plate. So equal amount of negative charge will be coming to this plate. Same way, positive charge will be induced on this one, inner one. Now here again, same amount of negative charge, and this positive charge is induced. Whatever electrons are there, it will go to the battery, that is source. So from here, electrons will start, and same amount of electron will go to the cell. That is, circulation will continue. So in this case, this circulation will be just for a moment. It will not be same as resistance. It will not continue. Just for a moment, it will move, and then this flow of charge will stop. So whatever current is produced in this gap, that current we call displacement current. Though actually there is no flow of charge. Here, air is present, so no flow of charge. The electron has not come to this place. Equal amount of charge has induced. So it simply appears that some current is flowing like through resistor. So whatever current is produced for a moment during the charging, that may be of millisecond, of the order of millisecond only, or sometime not even millisecond. So for the moment, whatever current is produced in the gap of this capacitor, that current we call displacement current. So till what time this flow of charge will continue, or not even flow, we can say this induction of charge will continue till what? Till the potential difference of the source and potential difference of this group is same. When the potential difference of this source and potential difference of this group from here to here becomes same, this induction will stop, or this displacement current will stop. So this displacement current will be only for a moment. So through the capacitor, this direct current can't pass. This capacitor is behaving like an insulator because air is there. So it is behaving like insulator for direct current. That is the current which is given by the battery or this DC source. So in case of DC source, if we connect, the current will flow for a moment. That current we call displacement current, and this flow will stop when the potential difference of the source and potential difference of this, if combination is there, then the combination. If only one capacitor is there, then only one capacitor. So in this case, what will be, whatever charge is given by the source cell here, same amount of charge is everywhere. So this will be minus Q charge, this is plus Q charge, again this is minus Q charge, plus Q charge, minus Q charge, this is plus Q charge. In case of series combination of the resistance, current was same. In class 10 we have done. Current passing through the resistance becomes same. Here in case of series grouping of capacitor, charge will be same. Potential difference across them will be different, but the combination whole will be same as that of source. Suppose the capacity of this capacitor is C1, this is C2, and this is C3. This is suppose point A, this is point B, this is point C, this is point D. Hello, light, na? So we are considering 3 capacitors. We can consider 3, 4, 5, whatever it is. So they are connected in same way. So generally we take 3 capacitors. Their capacity may be different, may be same, no problem. But in general, we are taking different capacity, C1, C2, and C3. So let 3 capacitors of capacity C1, C2, and C3 be connected to a source of potential difference V as shown in the figure. So as they are connected in series, therefore, in equilibrium, means steady state we can say, or equilibrium, steady state. So in equilibrium or in steady state, charge present on them will be same or will be equal, we can say, or same we can say. Let it be Q. Now we'll find, so as this is connected to positive, this is connected to negative, so what will be? The potential will keep on decreasing. So this is 10 volt, this is 0 volt. So from here, the voltage will keep on decreasing and finally it will come here 0. So potential difference means here this will be higher potential, this is lower potential. B will be at higher potential in comparison to C. C will be at higher potential in comparison to D. So we'll find the potential difference. Diagram, this one. So potential difference across first capacitor. This V1 which is equal to VA minus VB will be how much? Q over C1. So potential difference across first capacitor will be, similarly potential difference across second capacitor is V2 which is VB minus VC. So it is Q by C3. So this series grouping, we say it is potential divider arrangement. In class 10 also we have seen. In case of grouping of resistance, the series grouping means potential divider arrangement. So it divides the potential. So this potential of the source is 10 volt. It is divided into three parts, maybe equal, maybe unequal. If C1, C2, C3 all are equal, then this potential will be divided equally. If C1, C2, C3 is different, potential will be divided unequally, but it will divide the potential. That's why sometimes we say series is the potential divider arrangement, whereas parallel we say, in case of that one, we are saying current dividing arrangement. But here it will be, there is no current, so it will be charge dividing arrangement. Okay, so this is potential difference across individual. So naturally, what will be the potential difference between A and D? So potential difference between two and of the combination or group. This V will be how much? V1 plus V2 plus V3. So if you are adding these three, what will be? VC cancel, VB cancel, what is left? VA minus VD. If we add these three, V1 plus V2 plus V3 will be how much? Then VA minus VD, and this is this much. So Q we can take common, 1 by C1 plus 1 by C2 plus 1 by C3. Now, in place of this whole group, if we are taking only one capacitor, which when connected to same source, suppose this capacitor is here, so it is coming so in place of this group, if we are taking only one capacitor, which can produce same charge or which can acquire same charge from the same source as this combination, then this will be said as equivalent.
Equivalent.
So for equivalent capacitor, what will be? So let equivalent capacitor or effective of the combination be CS. Then for the equivalent, what will be? This V must be equal to Q over CS. So if we take this one as equation 1, this one as equation 2, now when we compare these two, what we are getting? Equation 1 and 2, what we get? this Q over CS will be equal to Q 1 by C1 plus 1 by C2 plus 1 by C3. So 1 by CS is 1 by C1 plus 1 by C2 plus 1 by C3. If only 3 are there, then this much. If many capacitors are connected, then what will be? This 1 by CS will be 1 by C1 plus 1 by C2 plus 1 by C3 plus so on, whatever it is. 1 by C4 plus whatever. Is it same as combination of resistance?
Parallel
No,
one.
sir.
No, sir. Same as
Parallel combination of resistance. Yes. So series combination of capacitor is similar to parallel combination of resistance. Good. Now, if all are equal, so when you are asked to derive the relation, only up to here, or up to here also you can leave, no problem. Sometimes 3 marks question is asked, derive the expression for equivalent capacity when capacitors are connected in series. Sometimes it will be written 3 capacitors are connected in series. Then only 3 we have to take. If nothing is written, up to here you can continue, no problem. So if an equal capacitor each of capacity C are connected in series, then what will be? Series equivalent will be how much? 1 by C plus 1 by C plus 1 by C plus so on, n terms. So series equivalent will become how much? C over N. So when we connect the capacitor in series, the equivalent will decrease. So suppose we are having capacitor of larger value and we want some smaller value, then we will connect them in series. Now series equivalent of 2 capacitors. If C1 and C2 are connected in series, then what will be? 1 by CS will become 1 by C1 plus 1 by C2. So C1, C2 will take LCM. So frequently we use this formula. C1 into C2 by C1 plus C2. For 2 capacitor, as in class 10 we have done, for 2 resistance, in parallel we are using R1, R2 by R1 plus R2. So same way here, when 2 capacitors are connected in series, then frequently we use this formula. We will not use this way. What is the problem? You will bring up to here and you will say this is the answer. So that is generally you will forget to inverse that. This is 1 by CS. So always we will use this formula C1 C2 by C1 plus C2. Now in this case, whatever the value of C1 and C2 may be, the value of CS will be always less than both. Now this CS will be less than C1 and CS will be less than C2. If two capacitors are connected in series, then their equivalent will be smaller than the smallest among them, whatever number may be. So if capacitors are connected in series, their equivalent will be smaller than the smallest among the group. For example, suppose C1 is 1 microfarad, C2 is 50 microfarad or 100 microfarad, and C3 is 1000 microfarad. What is the value of CS? Can you find? How much it will come? Can we use this formula for 3? Should we use this formula like that? C1 to C3 to should we use this one like this? C1 into C2 into C3 by C1 plus C2 into C plus C3?
No, sir.
So it can't be valid. So don't use this formula. So when it is more than 2, you will have to use the original one. That is what will be 1 by CS. So 1 by 1 plus 1 by 100 plus 1 by 1000.
Said 1000 by 1011.
So it is how much? 1000. 1101.
1011.
1101.
No. 1000. How many will come?
1011.
1000 plus 10 plus 1. Okay. Yeah, 1011. No. Is it correct?
No, sir, you have to invert that.
Yeah, I mean,
Thousand.
Yes, that is
1000
doing
by-
that. Yes, that is doing that.
I'm writing. So this much microfarad will be the series equivalent, which is less than 1. Among this group, the smallest is 1 microfarad, and the series equivalent is less than 1 microfarad. So this series equivalent is less than 1 microfarad. So whatever is smallest in that group will be, the series equivalent will be less than or smaller than the smallest. So series equivalent we use when we have to decrease the equivalent capacity. Okay, I think we should leave up to here. Tomorrow we shall see. So tomorrow also 70-minute continuous?
Yes, sir.
Yes, sir.
Yes. Okay.
Thank you.
Anyone having any other doubts to ask?
Thank you, sir.
No, sir.
Yes, sir.
No. Okay. And thank you.
Thank you, sir.
Thank you, sir.